So I'm sharing Choki. These are the objectives of today's lesson. By the end of this class, you should be able to, number one, identify and explain the structure of a class in Java, identify local and global variables in a class, identify the parts of a method, create an object of a class, explain the dot operator, appreciate and explain encapsulation, compile and run a program involving two classes in Java. So in our previous lecture, we were looking at parts of a method in Java, and we had an example class that we used, which was the class rectangle. So let us just go through that briefly again. So this is the class rectangle. So this is the name of the class, rectangle. As we had said, you declare a class by first using the keyword class, then followed by the name of the class. The class has two variables, which are global variables. You can see they are global because they are not declared within a method. So they are global variables. Now these two variables is length and width. Because they have the same data type, which is double, then we declare them together. We have already discussed that before. Then we have the class also has methods. So the first method is called setLength. So this is for changing the length of the class. So it has a return type as void because the method is not expected to return anything. And then it has the name is setLength. And then the parameter list is only a single parameter, which is L, and so which is of type double. So whatever value is applied to that method will change the value of the length. So this length here. So we also have another method, public double get area. So this method is different because its return type here is double. If you can note that, the return type is double. This means that once you call this method, then you are supposed to get an output from it. So its parameter is empty, so it has no input in itself. So it simply calculates the area and then returns a value. So I want you to look at the body of this method. So we have within the method we have a variable that we are calling AR. It's of type double. So double AR goes, then you are assigning a value to that variable by multiplying the length and the width of that class. So you can see that the length here, this dot length, is being accessed from this method, and this dot length is also being accessed from this other method here. Okay, so you're able to see that this variable, because it's global, is being accessed from different parts of the class. Now another thing that we had discussed earlier is that a method that has a return type must always have the return statement. So this method returns the variable AR once it's called. Now this variable AR is a local variable because it's defined within a method and it cannot be accessed in any other method, as you can see, because it is local. Now, so we have another method for getting length. So this one returns the length. So this is set length. We use that one to change the value of the length. So it's like to write the value to write the variable, write a value to the variable. And get length is used to return the value of the length. So this one we can say it's a reading method. This one reads the value of the length. This one writes the value of the value of the length. Now the one for reading does not have a parameter list. You can note that. But the one for writing has a value that we supply. So I hope you're able to see that and appreciate. So we have a similar one for reading the width, but note that we have not put one for setting the width, and so I want you to do that as your assignment. So add a method for setting width. Okay. Then we have another method for getting perimeter. So you can see this one has another local variable. We are calling it peri. So how do we get the perimeter? So we have a method for getting perimeter where we say it's 2 times, then we get the length and we add it to the width, and that sum is multiplied by 2 and then assigned to the perimeter, and then return the perimeter. So it has how many methods? It has so far we have 1, 2, 3, 4, 5. I've put 5 methods, but you can add more. Then we have a main method. This is the main method here. Okay, public static void main method. Now I want you to see. So we have created an object of the class rectangle. This is our class rectangle here. So for us to be able to access the variables or the methods of the class, we are not able to do that directly. So what we do is that we first create an object of the class. Okay, inside the main method. So you say rectangle R1. So R1 is an object of the class. Then we say equals new rectangle. So this is how we create an object of a class. Okay. Then from there, we want to change the value of the width of the class. Now remember that every time you create an object of the class rectangle, its width is put to 0.0 and the length is put to 0.0. But you can change that. And there are two ways of changing the values of the variables of a class, either by accessing them directly or by accessing them using the methods. So let's look at this one here. So you're saying r dot width equals 5.0. So you're saying the width of r1 is equal to 5.0. Then r1 dot set length. So we are telling this method to go and change the value of the length to 6.0. So these are two different ways. But in these two statements, I want you to appreciate that after R1, after the object name, we are using a dot. So we call this the dot operator. Okay, so we use the dot operator to access the variables and the methods of a class. We use the dot operator to access the variables and the methods of a class. So methods and maybe I can put this one here with a comment for you to understand, is that methods and variables are collectively referred to as members. So in other words, we are saying we use the dot operator or what we call the dot. Okay, so let me just call it the dot and I put it in bracket. We use the dot operator to access the members of a class. Okay, I hope you're able to see that and appreciate. Okay, so if for instance I create another rectangle here, copy, and this one I call it rectangle 2 R2, then because what you can do here is that we can repeat this statement so that we're able to see the difference between these two rectangles. I want you to follow this carefully. So this is rectangle 2, so I changed the details of 2. Okay, so now I want you to note that here we have created two objects. One is called R1 and the other one is called R2. So we have R1 and R2. They are object of the same class. Object of the same class. Okay, they are object of the same class. But then there are two distinct objects in that when we change the variables, the values of the variables of one, then the variables of the other one is not affected, and that is now what we call object oriented, where we have a class as a design of an object, and then you have the object as an instance of that class. So R1 is an instance of the class rectangle, R2 is an instance of the class rectangle. Each has its own length and width, and so it will have different values for perimeter and area. And what I want us to do is to simply run this class and we see the output. We run this class and we see the output. So how do we run the class? So we go to command prompt and we say command, we pick this path here, we change the drive to D, then we say cd space, and we open the folder, opening the folder where our code is, and we enter, and now we are there. And so we simply compile our code, javac rectangle dot java. We have talked about this before. So, and we run this. Very good, it has compiled perfectly. So what do we do then? So we now run by removing the .java and removing the C and the javac, and then we enter. There it goes. This is the output of our program. So let me explain a little bit of the command prompt commands that we put here. So we opened in our command prompt, we opened the drive C users PC. So we typed D semicolon to change the drive from C to D because that is where our work is. And then on D, then we said CD, meaning change directory. So we are changing now from the D drive and opening the folders where our work is. So we open the folder Moshiri work, notes, OP, and then after that, we now compiled our code, that is the rectangle.java class, by calling the Java compiler, which is javac, and then we put the source code, which is rectangle.java. So after that we enter and it compiles correctly. After we have compiled, then the next thing we were to do was to run the program. So we call the Java interpreter, which is Java, and then we call now the .class file, which is rectangle. So note here that we do not now need to put .java because the rectangle class is already compiled and now we have it as a Java file and we only need to run it. So once we run that and enter, then we get the output of our code, which is area of R1 is 30, perimeter of R1 is 22. So then area of R2 is 0, perimeter of R2 is 0. So you can see now that R1 and R2 as I had explained earlier, is that these are two different objects, but objects of the same class. So each of it has its own area, and the values for area and perimeter for the different rectangles are different because there are values also for the length, and the width for the two rectangles is also different. So this is where we said that an object is an instance of a class, but a class defines an object. A class is like a map. It's like a design for the object. Okay. So let's look at that code again. So if you look at our class rectangle, this is how it was. So we have said double length is 0, 0. So once you create an object of it directly, you get the length to be 0 and the width to be 0. And then we come to the main method where we created an object of the class rectangle, rectangle 1, and we also created rectangle 2, which is also another object of the class rectangle. Okay, and then, as I had said earlier, we changed the values of the length and the width by calling the length dot width 50. So here we are accessing the attribute width or the variable width and changing it directly. Here we are changing the attribute length by calling the method, let's see, by calling the method set length. So this method here, set length, and supplying 6.0 as a value for the new length. Okay, so I want you to note that once we change the attributes or the global variables for object R1, that does not change the attributes for R2. So it means R1 and R2, both of them are objects of the same class, but each is independent of each other. And then we can see the output being there, as we had said. So if you look at this output, this is the output here once we run our code. Okay. Now, there are a few things I want us to look at when you're looking at this code. We have created a single class called rectangle. Then inside the single class, we have the main method. If you look at the main method here, okay. And in a normal situation or in a real life program, you'd find that a software would have many classes, but then it only requires one main method. So we cannot have the main method in every class that we do. So to improve on this, we are going to rewrite this code now, but then we are going to have two different classes, and then we are going to see how this kind of program is compiled and run. Okay, so we are going to redo this program, but now you separate it in two different classes. We'll have one class that will have the main method, and the other class for the rectangle. So to do this, in my folder OOP where I was doing the work, I created a new folder. I called it practical, and then in it I've created the class rectangle. So I want you to look at this new class here, the class rectangle. Okay, so this class, we have class rectangle. It has the attributes length and width, just like as we had the other one. So the attributes are basically the global variables. They represent the data of the object of that class. So every rectangle would have a length and a width. So these are the attributes of a rectangle. The attributes are represented using global variables. It's good for you to note that the attributes are represented using global variables. Then we have the methods. So we have the method for set length, get area. We had done all this area before in the other class. And remember, I told you to do a similar method for setting the width. Okay. So we have get area, we have get length, we have for get width, and we also have for calculating the perimeter. So you can just check that. We have the same methods. So, but now in our new class, we do not have the main method here. So for us now to have a main method, for us to be able to run this program, because remember we said that the main method is used as the entry point for your program. So the Java program starts executing from the main method. So if there is no main method, then you are not able to run that program. So our class does not have the main method. So what we do, we have another class which we are calling main. So let's look at the main. So you say class main, so it adds here, but then the body of the class only has the main method.
Okay, so you can add other things, but then for this, so we pick the main method as it was and we bring it in this class. So we now have two classes. Okay, for the purposes of our program here, we have two classes now. So we have one class that is the class rectangle, and we have another class that is the main class. So how do we compile this kind of a program? Now, for us to do this, two things are important. That class main has an object rectangle, so it means it's referencing rectangle. Okay, so you cannot compile this class if the class rectangle does not exist. That means that we need to first compile the class rectangle because it is referenced from here. Okay, so for us to be able to run this program, we are going to do two things. So we say cd prac. So we open the folder that has our code, and there it has opened. Then we now compile the class rectangle, compile java rectangle.java. Okay, if it compiles correctly, then after that we now compile the main, the class main, the one that has the main method. So this order is very important, that we started with compiling the class rectangle, then compiling the class main. Okay, why? Because the class main is referencing rectangle, so you cannot compile main before compiling rectangle, otherwise it will generate an error. Now we enter, and very good. So you can see it has compiled successfully. If it does not generate an error message, then it means it has compiled successfully. Then from there we now run the class with the main method. So notice that we will not run the class rectangle. We do not run the class rectangle because it does not have the main method. So the class that we are going to run now is the class main, because it's the one that has the main method. Then from the main method, then the code that is in the main method is what will be executed. So if we run that, you can see that it generates the same output as we had. Okay, so what has happened here? So you can see that in the main method we have created an object of the class rectangle, and then we have also created another object of the class rectangle, and now we have had this output. So a few things that I want us to note here. Number one is that to create the object of a class, we have used the class as a data type. So in this case it's a rectangle, then R1, then equals new rectangle. So this is just like the way you declare a variable, for instance a variable double y, okay, or integer a, like that. So we are also declaring another variable, quote in quote, okay, but now of type rectangle. So we use the class as a type, and then you put a new place for holding data. But now these ones are objects, they are not variables, they are objects, but we declare them just like variables. And if you remember that we had said earlier, when we are discussing data types, we had said earlier that we have different types of data types, if you remember, and we classify data types into two types. We classified data types into two types. We say that we have what we call primitive types and derived types. For derived types, we say they are classes and interfaces. Okay, and now you can see the way we have created rectangle is a class we have created ourselves. Now we are using it now as a data type. That makes it a derived data type. Okay, but then inside the class rectangle, it has its own attributes. That is in form of global variables. That is the length, for instance, and the width, and it has its own methods, which are operations or operations of the data that is within the rectangle. So these are methods that operate on the data of the class. So that enclosing of data and the methods that operate on that data. Okay, so the attributes and the methods closed together to form a unit is what we call encapsulation. Okay, is what we call encapsulations. So encapsulation is enclosing attributes or data and methods, that is the operations on that data, into a single unit, which is a class. That is what we call encapsulation. And now we can reference, when we talk of R1, for instance, in this case, R1 within it, it is a single, it's like a single variable, but within it we have other variables and other methods within it that we're able to reference. Like here you can see we are referencing the width attribute, and we are also referencing the set length method of this object. Yet we have just declared it the way we declare other variables, so to say. So that is what we refer as encapsulation. What is encapsulation? Enclosing attributes and the methods that operate on those attributes to form a single unit, which is a class or an object. That is what we refer to as encapsulation. Okay, very good. Now, when we are creating an object, I also want you to note here that once we declare the class as the data type, and then we put the name of the object. So our R1 and R2 are the names of the objects that we have chosen to create, but these objects are of type, they are of type rectangle. Then we say equals, now to instantiate, that is to create the instance of the class, to create the instance of the class, or to create that object, we call it instantiation. So to instantiate is to create an object of a class. To instantiate, we use the new operator. So we use the keyword new, followed by a method that has the same name as the class. Okay, so we can see that you are calling a rectangle followed by the parenthesis. Every time you call something with the parenthesis, these two brackets here, then you should always know that that's a method we are calling. So to create an object, we use the keyword new followed by a method that has the same name as the class. We shall discuss more of this. Okay, so you can see it's the same thing we have done here. So that is how we create objects. Okay, that is how we create objects, by creating a variable of the data type, that class, then followed by equals new operator, and then calling a method that has the same name as the class. So a method that has the same name as a class is referred to as a constructor method. Constructor method. So this is a method that has the same name as the class, and it returns an instance of the class. As such, then we can say it is used to create objects of a class. We shall discuss more of this later on. We shall discuss constructor methods in more details later on, but it is good that you know that for now. Okay, it is important that you know that. So in this case, the constructor method is rectangle method. Okay, so we shall discuss more. So to create an object of a class, you need to call its constructor method, but you call it using the keyword new. So you say new, then call the constructor method. It creates an object. So here we have two objects, R1 and also R2 of the rectangle class. So one has, we change the width, and here we change the length. I also want you to notice that to access the values, to access the members of a class, or to access the attributes of a class, or to access the methods of a class, then we are using the dot operator. We had discussed that earlier. You're using the dot operator, where you say the name of the object, then dot, then you access whatever it is you want to access. So to access the methods or variables or attributes of an object, we use the dot operator. To access the methods or attributes of an object, we use the dot operator. So when we talk of the methods, or so you're saying we use the dot operator to access the members of an object or a class. So when you talk of members, members refers to attributes or methods of a class. Okay, so you can see that in this folder we have our class main and we have our class rectangle. So once we compile the main class, then the source code, then we got a main.class, that is our bytecode for the main class. The rectangle class we compiled, we got rectangle.class, which is a bytecode for our rectangle class. So I want us to look at what we were supposed to cover for the lecture. So we are to look at the structure of a class, and we've already looked at that. We have seen how we create a class with a class name, then it has the attributes, and then which are global variables, and then it has methods. We have looked at local and global variables, where we have identified local variables, which are variables that are declared and used within a method, and global variables, which are basically the attributes of a class, which are variables that are declared outside the method. We have also identified the different parts of a method. We have also created objects, and we have seen how to create objects using the constructor method and using the new operator. We have also explained the dot operator, which is used to access the members of a class or members of an object. We have explained encapsulation, which we have said it is enclosing the data which represents attributes and the operations of that data, which is represented by methods. All together, you put them together to form a single unit, which is a class or an object. And then we have seen how to compile a program that has two classes by compiling the rectangle class and the main class. And that then, ladies and gentlemen, brings us to the end of today's lesson. Thank you very much.